Einstein gravity paradox. Imagine a substance so alien, so fundamentally wrong, that it actively wages war on reality itself. Not something that's merely immune to gravity, floating weightlessly in the void. No, this is far more sinister. This is matter that feels the gentle curve of space-time and decides to climb the hill instead of rolling down. It's a substance that doesn't just ignore the cosmic dance of attraction that binds galaxies, stars, and planets together. It actively pushes back. It is the universe's ultimate saboteur. This is the concept of ghost matter, and it represents a paradox so profound that it would have been a true nightmare for Albert Einstein, a man who dedicated his life to revealing a universe of sublime, elegant order. To understand why this idea is so terrifying, we first have to appreciate the beautiful architecture it seeks to destroy: Einstein's theory of general relativity. Before Einstein, we had Newton. For Newton, gravity was a mysterious force, an invisible rope pulling objects toward each other. It worked, it was predictable, but it lacked a deeper explanation. Einstein saw something different. He imagined that space and time were not a static backdrop for events, but a single, dynamic entity, a four-dimensional fabric he called space-time. He proposed that massive objects, like our Sun, don't pull the Earth with a force. Instead, the Sun's immense mass warps and curves the very fabric of space-time around it, like a bowling ball placed on a trampoline. The Earth, trying to travel in a straight line through this curved space, is guided by the contours of that curve. We perceive this guided motion as the orbit of gravity. It's not a pull, it's a push from space-time itself, a celestial river guiding everything along its currents. This is the core of general relativity, and it's been one of the most successful theories in the history of science. It predicts the bending of starlight, the wobble in Mercury's orbit, and the existence of gravitational waves, ripples in space-time itself. At its heart is a simple, profound relationship. Matter tells space-time how to curve, and curved space-time tells matter how to move. This elegant dance is universal. It applies to apples, planets, stars, and entire galaxies. But what happens if something refuses to dance? What if something hears the music of the cosmos and decides to move in the opposite direction? This is where the nightmare begins. Enter ghost matter, or what physicists would more formally call exotic matter with negative mass. Let's be crystal clear about what this means. It is not antimatter. Antimatter has positive mass and positive energy. It interacts with gravity just like normal matter. If you dropped an anti-apple, it would fall to the ground. Ghost matter, however, would have negative gravitational mass. If you could hold a chunk of it and let go, it wouldn't just float. It would accelerate violently, away from the Earth, as if repelled by the planet's gravitational well. This single, bizarre property unleashes a cascade of paradoxes that unravel the very logic of physics. The most famous of these is the runaway motion paradox. Imagine you have a ball of normal, positive mass matter and a ball of this negative mass ghost matter. The normal ball, with its positive gravity, attracts everything, including the ghost matter. So the ghost matter ball starts moving the normal ball. But here's the twist. The ghost matter ball has negative gravity. It repels everything, including the normal ball. So the normal ball starts moving from the ghost matter. Think about what's happening. The ghost matter chases the normal matter while the normal matter flees from it. The result is the pair of objects accelerating together in the same direction, indefinitely, seemingly out of nowhere. This isn't just weird, it's a blatant violation of some of the most sacred laws in physics. It violates the conservation of momentum and the conservation of energy. You'd be creating kinetic energy from absolutely nothing, a perpetual motion machine that breaks the fundamental accounting of the universe. For a mind like Einstein's, which sought a unified and consistent description of reality, this would be an abomination. It suggests the universe has a back door for creating free energy, a cheat code that would make the cosmos fundamentally unstable and nonsensical. It breaks the rule that you can't get something for nothing. This concept was so problematic that physicists, including the brilliant Hermann Bondi in his work on general relativity in the 1950s, studied negative mass and concluded it led to these kinds of logical inconsistencies. While Einstein himself didn't focus on it extensively, the implications would have been clear to him. It directly attacks the foundational principles he worked to establish, particularly the equivalence principle, which states that gravitational mass and inertial mass are the same. With ghost matter, they would be opposites, shattering the geometric heart of his theory. This is the true nature of the nightmare. It's not just a new strange particle. It's a logical impossibility that, if it existed, would prove that our entire understanding of the universe, from the motion of planets to the very concept of energy, is built on a foundation of sand. Impossible ghost matter. So, we've established that this ghost matter is a universe-breaking paradox, a theoretical monster that rips up the rule book of physics. But let's indulge the nightmare for a moment. If we were to suspend our disbelief, what would this impossible substance actually be like? And what catastrophic impact would it have on the cosmos? The properties of ghost matter are even more bizarre than its anti-gravitational nature suggests. Because it has negative mass, it would also have negative inertia. Newton's famous law, force equals mass times acceleration, gets turned on its head. If you push on a ball of ghost matter, it would accelerate you. To make it move away, you'd have to pull it. Every interaction would be a counterintuitive, backwards experience. Furthermore, because its gravity is repulsive, ghost matter could never form large objects. Normal matter clumps together. Gravity pulls atoms into dust clouds into stars, and stars into galaxies. It is the great architect of cosmic structure. Ghost matter, however, would repel itself. Every particle of ghost matter would actively push every other particle of ghost matter away. It would be doomed to exist as an infinitesimally thin, diffuse gas, a true ghost spread across the universe, unable to coalesce or form anything of substance. It would be the cosmic embodiment of entropy, a force for dissolution. Now, does anything in our real universe even remotely hint at such behavior? The most tempting comparison is dark energy. Astronomers in the late 1990s discovered that the expansion of the universe is accelerating. Something is pushing everything apart, counteracting the pull of gravity on a cosmic scale. This something was named dark energy, and it is often described as having a negative pressure, which creates a repulsive gravitational effect. However, this is where the comparison ends. Dark energy is thought to be a property of space-time itself, an intrinsic energy of the vacuum. It is not matter that you can hold or interact with. It's a smooth, constant pressure that acts everywhere, not a collection of particles with negative mass. While it creates a repulsive effect, it doesn't lead to the runaway paradoxes of ghost matter. Theoretical physicists, however, have encountered the something like ghost matter in some of their most mind-bending theories. To create a stable, traversable wormhole, a theoretical shortcut through space-time, you would need to prop it open with a substance that has a negative energy density. This exotic matter would possess the anti-gravitational properties needed to prevent the wormhole from instantly collapsing. But even here, it remains purely theoretical, a mathematical requirement for a sci-fi dream with no evidence that it can or does exist. So, let's return to the nightmare scenario. What if, against all odds, a significant amount of true ghost matter was created in the Big Bang? The consequences would be catastrophic. The delicate balance between the initial expansion of the universe and the gravitational pull of matter, which allowed galaxies to form, would be shattered. The repulsive force of ghost matter would have supercharged the expansion, tearing apart the primordial clouds of gas before they could ever collapse into the first stars. Our universe would be a cold, dark, and empty void, with no galaxies, no stars, no planets, and no life. Even a small amount entering our solar system today would spell doom. A rogue cloud of this substance would push and pull on the planets in unpredictable ways, flinging Earth out of its life-sustaining orbit, sending it either into the frozen depths of space or on a collision course with another celestial body. The stability we take for granted would be revealed as a fragile truce, easily broken by a substance that doesn't play by the rules. Ultimately, the existence of ghost matter is a philosophical nightmare as much as a physical one. The entire project of modern physics, from Einstein onwards, has been a search for unity and symmetry, the belief that a few elegant universal laws govern everything. Ghost matter is the ultimate wrench in these works. It suggests a universe that is not elegant, but fractured and illogical. It's a terrifying possibility, a hint that beneath the orderly cosmos we observe, there could be a fundamental lawlessness that could, at any moment, break reality itself.